So, have you ever wondered how different apps just talk to each other instantly? How your online store knows a payment went through right away, or how your code just deploys the second you push it to GitHub? Well, the magic behind all of that is a pattern called webhooks, and they are one of the most important building blocks of the modern web. Let's get into it.
All right, here's our game plan. We're going to start with the old, inefficient problem that webhooks were invented to solve, something called polling. Then, we'll get into what webhooks actually are, how they work under the hood, see a real-world example, cover the super important security stuff, and finally, figure out exactly when you should and shouldn't use them.
To really get why webhooks are so brilliant, you first have to understand the pain they replaced. And that pain, that inefficient and wasteful process, is called polling. I want you to imagine you're waiting for a package you're really excited about. Would you call the delivery company every 5 minutes and ask, "Is it here yet? How about now?" Of course not, right? It's a huge waste of your time and it completely ties up their phone line. But believe it or not, this is exactly what applications used to do all the time. In the software world, we call this constant checking polling. Your app, the client, is just constantly hammering another server with requests over and over, asking, "Hey, you got anything new for me yet?" And well, most of the time, the answer is just a flat nope. And all of that asking comes at a huge cost. Every single one of those no answers still eats up CPU cycles. It takes up network bandwidth on both sides of the conversation. And if you're working with a third-party API, you can burn through your rate limits in no time. It's just incredibly slow and wasteful, especially when the updates you're waiting for don't happen very often. So if polling is like constantly calling the delivery company, there has to be a better way. And there is. It's all about flipping the entire model on its head. We stop polling for information, and instead, we have it pushed to us.
And that is exactly what a webhook is. It's like telling the delivery company, "Here's my phone number. Just call me when the package arrives." It's an automated message, sometimes called a reverse API or an HTTP callback, that gets sent from one server to your application the very moment a specific event happens. This right here is the aha moment. It really boils down to this. Polling is a pull system. Your client is doing all the work, constantly asking for data. Webhooks are a push system. The server takes charge and sends you data only when it has something new to say. The difference in efficiency is it's night and day.
Okay, so we get why webhooks are so much better, but how do they actually work under the hood? Let's break down the core technical pieces that make this whole push model possible. Now, this is the key technical twist, and it's something that can trip people up at first. See, normally, your application is a client. It only makes outgoing requests. But to receive a webhook, your app also has to be able to accept an incoming request. That means you have to set up a public URL, an endpoint that's just sitting there, listening for another server to send in an HTTP post request. So the whole thing kicks off with an event. This is the specific trigger you actually care about. It could be payment succeeded in a system like Stripe, a push event in GitHub, or maybe video.processed in a media service. This is the what that starts the whole domino effect. Next up, you have the webhook URL. This is the where. It's your app's public address that you register with the source service. You're basically telling them, "Hey, when that event happens, I need you to send the notification right here." And finally, there's the payload. This is the message itself. It's all the rich, detailed data about the event, usually sent in a nice, structured JSON format. It's got everything you need to know. The customer ID, the payment amount, the commit hash, all the good stuff is right in there. Okay, theory is great, but let's make this real. Let's see how these three pieces, the event, the URL, and the payload, all come together in a super common real-world example, processing a payment with Stripe. So check out this life cycle. Step 1, registration. You go into your Stripe dashboard, give them your URL, something like myshop.com/webhooks, and you tell it, "I want to listen for the payment.succeeded event." Step 2, the trigger. A customer buys something from your site. Boom. Step 3, the post request. Stripe servers instantly build that JSON payload and fire it off to your URL. And finally, step 4, action. Your server catches the payload, verifies the payment was real, updates the order in your database, and sends out that confirmation email. All of it happens in real time with zero polling involved. Now, this all sounds pretty amazing, right? But because your application is literally opening a door to the public internet, there are some absolutely critical things you have to get right when it comes to security and reliability.
This is so important. Your webhook URL is public, which means anyone on the internet could try to send fake requests to it. You must verify that every single request is legitimate. The way this is usually handled is with a cryptographic signature. The service sending the webhook will include a special header, often an HMAC hash that's created using a secret key only you and they know. Your server then does the same calculation on the payload it received and checks if the signatures match. If they don't, you throw the request away.
And beyond security, there's reliability. First, webhooks are asynchronous, which means you can't guarantee the order they'll arrive in. You might get an order updated event before the order created event. And even more importantly, if a provider doesn't get a successful response from you, they'll often try sending the same event again to make sure you get it. This can lead to duplicates. You definitely don't want to accidentally charge a customer twice or ship two identical orders. So to handle those duplicate events safely, your webhook handler has to be what we call idempotent. This concept is absolutely essential for building reliable systems. I know idempotency is a big, nerdy word, but the concept is actually pretty simple. It just means designing your code so that running it multiple times with the same input produces the exact same result as running it just once. For webhooks, this usually means grabbing the unique event ID from the payload, checking if you've already processed that ID, and if you have, you just safely ignore it. Simple as that. All right, we've covered a ton of ground. So now let's zoom out and figure out where webhooks fit into the bigger picture. Because like any tool, they're perfect for some jobs and really not the right choice for others. So where do webhooks really shine? Well, they're perfect for long-running, asynchronous tasks. Think of kicking off a video transcoding job and just getting a ping when it's done. They're also fantastic for keeping data in sync between two different servers, like updating an order status. And of course, they're the lifeblood of third-party integrations, like triggering your build pipeline every time new code gets pushed. But, and this is a really important but, it's crucial to know when not to use them. Webhooks are for one-way, server-to-server notifications. If what you need is true, real-time, two-way communication, like for a chat app or a live stock ticker, then webhooks are the wrong tool. For that, you'd want something like WebSockets, which keeps a persistent, stateful connection open for that constant back-and-forth data flow. So there you have it. By shifting from the constant question of, is it here yet? To the simple statement, tell me when it happens, webhooks have become the backbone of modern event-driven systems. They're not just a neat pattern. They represent a fundamental change in how we build efficient and interconnected software. So the only real question left is, what inefficient process in your next project are you going to replace with a webhook?